Okay. Good morning, everybody. I hope you have your packets in front of you, your 5.6 packets. If you remember, yesterday we were doing our guided notes for Monday, but we didn't do the very last problem on the second page. The reason for that is because it's a little bit different than the other problems. What we're trying to do in example 4 and what we did in example 3, 2, and 1 is we're starting from a formula and we're trying to draw a graph that represents the solution set. When we're dealing with inequalities, our solution sets are going to be an entire half of a graph. So we're going to have a boundary line, and then we're going to shade one side of that boundary line. And all of the points in the shaded region, plus potentially the points on the boundary line, are part of the set of solutions. So that's what we're doing in number 4. In order to draw this, the most important thing that we need to do first is figure out what our boundary line looks like. And that's just as simple as drawing a line. The method we typically use for drawing a line is to get our formula into the form y equals mx plus b. That tells us what our m and our b values are, and we can very easily draw the line from there. So that's where we're going to start with example 4. We need to get this in the form of y equals mx plus b. So let's pretend, I'll just rewrite this. 2x minus 3y is less than or equal to 6. Let's pretend that instead of an inequality, we just had an equal sign here. What would we do in order to get the y by itself on the left? Well, we'd have to get rid of this and this. We always will try to get rid of the other term first by subtracting. So the first step is going to be to subtract 2x from both sides. Normally, it would be both sides of the equal sign, but this time it's both sides of the inequality sign. So we're going to subtract 2x, and on the left, these cancel, leaving me with a negative 3y is less than or equal to negative 2x plus 6. For our next step, we need to get that y by itself on the left, so we have to get rid of the negative 3, or in other words, we have to undo the negative 3. The negative 3 is currently being multiplied to the y, so to undo multiplication, we have to divide. So we'll divide both sides of the inequality by negative 3. This cancels. So on the left, we'll have a y, and on the right, we'll have a positive 2/3 x minus 2. Notice I left my inequality blank. There's something really, 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 really important I have to share with you right now. You need to put this in your notes. Find a spot for it. If it doesn't fit down here next to your number 4, find another place somewhere on your document. Write important in big letters, maybe even use a highlighter. This is very, very important. With inequalities, whenever you divide or multiply both sides by a negative, the inequality reverses. This is super, super important. It only happens when we divide or multiply by a negative. It reverses our inequality. Let me show you why that happens. Let's take a quick example. You don't even have to write this down. You can just look up at my screen and just kind of follow along in this box. If I have, let's say 1 is less than 5. That's true, right? That makes sense. But what happens if I divide both sides by -1? On the left, I end up with a -1, and on the right, I end up with a -5. So basically what happened was we just switched our signs. When you divide by a negative, it switches your signs. Well, this is no longer true. -1 is not less than -5. In fact, it's greater than -5. Like if we start at 0, we have to count down to -1 and then count down even further to -5. So -5 is lower. So dividing by a negative took our inequality symbol and it flipped it around. It made it the opposite. So that is a rule that we're going to have to apply whenever we're doing algebra with inequalities. If you divide by a negative, you have to reverse your sign. So this becomes a greater than or equal to symbol. Very, very, very important. All right, I hope you've written down this important message because now I have to scroll back to the left and it's going to disappear off the side of the screen. Okay. So now that we have our equation written in mx plus b form, it's pretty easy to find the m. Use a different color. It's pretty easy to find the m and to find the b. We're going to use that to draw our boundary line, starting with our b, which is -2. That's our y-intercept. And then our slope is +2 over 3. So our rise over run is 2 over 3, up to right 3. And I can take that pattern in the other direction as well. Now it's time to draw our boundary line. Pay attention to whether we want a dotted or a solid line. Since our inequality has an equal to component, we're going to use a solid line. That's a terrible line that doesn't even really go through my points, but hopefully you understand what I'm trying to do there. The last thing we need to do is shade. We're either going to shade above the line or below the line, depending on our inequality symbol. But be careful here. We need to use our final symbol, the one we ended up with. We're not going to use the symbol we started with. We made a lot of changes between the beginning and the end. We're going to use the symbol we ended up with. So this symbol is y is greater than or equal to, which means we shade above. So from my line going up, we're going to shade everything above that. So just fill that in with a nice little shade. And that is our solution set. Everything from that line and up is our set of solutions to this problem. Okay, so that concludes our notes from Monday's guided notes. I wanted to do this today because I wanted to give this problem number 4, a good, solid explanation. I didn't want to try to rush through it at the end of class last time. But now we're ready to move on to Tuesday's guided notes, and I promise you this won't take very long. This is 5.6 guided notes part 2. We've talked already about going from a formula into a picture of a graph. That's what we just did. Now we're going to do the opposite. We're going to go from a picture of a graph into a formula. So let's assume we're given a picture, like the one on the right-hand side of your screen. The steps to turning this into a formula are to first identify our boundary line. We know how to do this. This is just finding the equation of a line using a picture. You find your b, which is your y-intercept. And in this example, it looks like our b is -2. You find your slope. So I'm going to pick 2 points, and I'm going to get my rise over my run, which looks here to be +2 over 1, which is just 2. And then once we have our m and our b, that helps us write the equation of the boundary line, y equals mx plus b. So in this example, mx plus b is actually 2x minus 2. So we know what the boundary line formula is, but this is written as an equality. We don't want to do that. We want to write it as an inequality. So instead of an equal sign, we need to replace our equal sign with one of these symbols. Greater than, less than, greater than or equal to, less than or equal to. So let's figure out which one. First, we have to pay attention to whether our line is solid or dotted. If it's solid, our sign is going to have an equal to component. If it's dotted, we will just have a strictly greater than or a strictly less than component. That's it. Finally, we have to figure out whether we're talking greater or less than. So that's where the shaded region comes in. We use this shaded region to figure out whether it's greater or less. Now, I recommend that you ignore this. The instructions written here under part 3, that's the long way to do it. It does work. Remember what this represents. This graph represents all the points that make an equation true. So one thing you can always do is pick a point and see if it makes your equation true. But that takes a while. There's a shortcut. I like the shortcut. The shortcut is if the shading is above the line, then we use a greater than or equal to sign. Above means greater than. If the shading is below, we use a less than or equal to sign. Simple as that. So here's a little shortcut. I like the shortcut way better than the stuff I just crossed off. So I'll save you some time and just give you the shortcut. Time to put our examples to use. We already figured out, for this example up here on the right, we already figured out that our m is 2, our b is -2, our mx plus b form is 2x minus 2. Now all that's left is rewriting this with an inequality symbol instead of an equality symbol. So based on whether our line is dotted or solid, we're gonna include an equal to component. So looking at our picture, we have a dotted line. That means we're gonna be using this type of symbol with no equal to component. Now we look at the shading. We have shaded above the line. I completely covered it up here with all of my marks, but we've shaded above the line. And according to our little cheat sheet down here, above means greater than. So our symbol is going to look just like this. Y is greater than 2x minus 2. And that would be the answer for this example. So let's move on and do some more examples where we are asked to write an inequality for each graph. Starting with the first one. Let's identify the m and the b of the boundary line. Now, I think this one goes through +1. That's our y-intercept. So b is 1. And then let me find another good point. It looks like we go through this point here. So our rise over run would be +1 over 2, making our slope 1/2. That means if we were to write this in mx plus b form, we would write y equals 1/2 x plus 1. But notice I didn't put the equal sign. That's because we're trying to find an inequality, not an equality. So I need to use an inequality sign, and I'm going to use the picture of the graph to help me figure out what type of sign to use. This is a solid line. So that means my inequality is going to have an equal to component. So I'm going to go ahead and put that on here. And since we shaded below the line, that means I'm dealing with a less than situation. So those two facts combined help me figure out that I need a less than or equal to inequality symbol. And that's our answer. Not even a lot of scratch work to do here. Really just looking at the graph and writing down the facts. The second example, pretty similar. We need to start by identifying our M and our B. That will give us the information we need to find our boundary line. I think B is about right here. That looks like 1, 2, 3, 4, positive 4. And our M, let's try to find a good point. I think it goes through here. So our rise would be 1, 2, 3, and our run would be 3. Rise over run, 3 over 3, would just simplify to a positive 1. So now we can write this in mx plus b form, which is y equals mx plus b. Instead of an equals, though, I just left a blank. And you also don't have to put the 1 there, the 1x. You could just write it as x plus 4. All right, now it's time to figure out what type of inequality sign we want to use. Based on the fact that this is a dotted line, I know that my symbol is either going to be one of these. There will be no equal to component in the inequality. And based on the fact that the shading is above, we know it's going to have to be a greater than or equal to symbol. So based on these two pieces of information, I know I'm going to need this symbol. Y is greater than x plus 4. And that's your inequality. So hopefully we're getting a little faster at this. I'm going to move on to the third example now, starting with trying to get the M and the B for the boundary line. This is a really blurry picture, but I'm thinking that we cross the y-axis at about this point, maybe -3. It's a little hard to tell. And then I'll identify another good point. 1, 2, 3. How about this one? Which gives me a slope of 3 over 1. Rise over run, 3 over 1, which simplifies to positive 3. Now we have enough information to write this in y equals mx plus b form. But again, I left the equal sign blank. I didn't put anything there because we're looking for an inequality symbol. We have a dotted line, which means we're dealing with one of these symbols. And we shade above, again, which means we're dealing with a which means we're dealing with a greater than or equal to symbol. So this is the one we want. The same as the one we used on the second example, actually. Which makes sense because these two graphs kind of look similar. The boundary line is in a different place, but they're both dotted and they're both shading up. So our symbol is the same for both of them. Okay, we've got one more example to do today, and it's a word problem. You've seen word problems like this before, but there's really only one kind of minor difference that makes this an inequality problem, as opposed to an equality problem or an equation type of problem that you're used to dealing with. So let's read this together. A Boy Scout troop sold cider and donuts to raise money for charity. They sold boxes of donuts for $1.25, and they sold cider for $2.50 a gallon. In order to cover their expenses, they need to raise at least $100. We're going to write an inequality, and then we're going to draw that inequality on the graph. So those are our two goals. Write the equation, write the inequality, and then draw it. So let's break this question down piece by piece. First of all, we're dealing with two different types of products. We've got cider and we've got donuts. Let's call the cider, let's call that X. And let's call donuts Y. We just need to give them a variable so that we can write an equation about them. We are told in the next sentence that donut holes cost $1.25. So to represent the amount of money they made from donuts, we are going to multiply 125 times Y. Y stands for donuts. The next piece of information we're told is that cider costs $2.50. So we're going to multiply $2.50 times X. So this represents how much money they made from donuts. This represents how much money they made from cider. To understand the total amount of money they made, we'll just add these two things together. So 1.25y plus 2.5x. Here's the tricky part. Here's the part that makes this an inequality. The last sentence says, in order to cover their expenses, they need to raise at least $100. That wording is very important. It doesn't say they need to raise exactly $100. That would be equals $100. This is at least $100. So this could be bigger than or more than $100. That would be fine. But $100 is the bottom, is the minimum that we want. So this amount that we earn has to be greater than or equal to 100. That's what that symbol means. Sorry, having pen issues. Okay, so the at least becomes a greater than or equal to sign. Now we're just looking at an inequality that we can move around and manipulate to get it into y equals mx plus b form. So to get that form, we need y by itself on the left. I'm going to start by subtracting 2.50x from both sides. So now we're looking at 1.25y is greater than or equal to negative 2.5x plus 100. And to get that y completely by itself, we have to undo the 1.25, which is being multiplied. To undo a multiplication, we divide. Both sides, actually. And now, this might be a job for a calculator. I'm feeling a little lazy here, so I'm going to pull a calculator out, and we're going to plug in negative 2.5 divided by 1.25, which gives us oh my goodness, guys. I didn't look at the graph until just now. They have it set up so that cider is y and donuts are x. You know what? We can fix this. I'm just going to cross this off. I'm going to write donuts. And you should do the same. Cross this off and write cider. Lesson to the y's, though. Look at your picture. They actually had already defined what x and y was. So when I just arbitrarily chose to make cider x and donuts y, I chose backwards. I didn't realize they had already defined cider and donuts for me. This is going to change our answer, but that's okay because I just changed the graph instead. Sorry for the interruption. Let's go ahead and do this simplification. When we take negative 2.5 divided by 1.25, we get negative 2. And then when we take 100 divided by 1.25, we end up with 80. So this is our mx plus b form. We're going to use this to draw our boundary line and then do our shading. So our m is -2, and our b is 80. So let's start with b. Our y-axis is all the way up here at 80, or our y-intercept. And then from here, we have to count a slope of -2, which would be -2/1, which is down to right 1. So about here. And we can do that again, down to right 1, down to right 1, down to right 1. Just over and over until we end up with a nice linear pattern. Let's draw the boundary line. To decide whether to use a solid or a dotted line, we're looking at this symbol, and specifically, since there is an equal to component here, we're going to use a solid line. So this gets made solid. Finally, it's time to shade. For shading, we look at this component. Since this is a greater than symbol, we shade above greater than. So we're going to go up from the line, shade this whole area here. The shaded section, let's talk about what this means, what this graph actually represents. All of the blue, every piece of blue that you can see, all the points on the line, all the points in the shaded area, any point in blue represents an area where the Boy Scouts make at least $100. So take this for example. This point, the red point, represents 50 cider and 30 donuts. If the Boy Scouts sell 50 ciders and 30 donuts, they will make more than $100. If they sell 20 ciders and 60 donuts, they will make at least $100. If they sell 60 ciders and no donuts, 0 donuts, they will make more than $100. So any point over here represents the Boy Scouts making at least $100, so probably more. Even this point right on the line, a point exactly on the line represents the Boy Scouts making exactly $100. Exactly 100, which is okay because we have this or equal to. It can be or equal to $100. So these points all represent exactly $100. These points represent making more than $100. It's pretty nice. There is a logic behind what this actually means. So I just wanted to tie together the solution we got with the meaning and the interpretation of what this information represents. Okay, we made it. We're done. That is the end of the guided notes for today. As homework, please take a picture of your completed guided notes and post it on Canvas under the proper assignment submission button. I also want to give you a little reminder about tomorrow. We obviously aren't going to meet live, but you do have a virtual learning activity that you have to complete at some point tomorrow. It's a Kahoot, and this reminder is really important. Some people are forgetting this. When you submit a Kahoot assignment, there are 2 things you have to include. 2 things. You have to submit a picture of the Kahoot page itself as proof that you did the Kahoot. And you also have to submit a picture of your work. So like take your cell phone, snap a picture of your scrap paper that you use to work out the problems. If you don't do both of those things, you won't get full credit. And I hate it when students do the work and they don't get the credit. So please, please, please include both things on your submission so that you'll get full points. All right, I'll be here for the next few minutes if anybody wants to ask any questions. Otherwise, you are free to go, and I will see you on Thursday.